Okay, um, we'll go through these two questions in different order. This one here, the amplitude of g of x equals 1 minus 4 sine 3x is one of these ones. Well, the amplitude is always a coefficient of the function, so it ends up being at 4. That's what you get. So amplitude there is 4. Now, let's have a look at this one. Function f of x undergoes the following transformations. So, what we want to write this in terms of f of x, which then becomes f, I'm writing this hopefully like this, it'll work, a times f of 1 over n, open bracket, x minus h, whoops, close off the bracket, and we say plus k. That's how we want it written. So what we're going to do here is we're going to try and kind of fill this in as the way we had it originally. So, so a times f bracket 1 over n bracket x minus h, close the bracket, say plus k. And what we're going to do, we're going to basically fill this into here. So first thing that happens is a reflection in the x-axis. So if there's a reflection in the x-axis, this is going to be negative. Now we're being dilated from the y-axis, so that means that we can get rid of this. We can just leave that as being negative f. Now over here we are dilating 2 from the y-axis, so that means this here needs to be 2, and we are translating 1 to the positive direction of x, so it stays minus because it is positive direction of x. This becomes 1, and now translation of 3 units in the negative direction of y, so we'll have minus 3. So that's what we're going to do for that. So that's what we've ended up with there. Now what we can do is we can say that we're going to basically copy this into f of x. So we're going to define f of x equals, we know it's the square root of x, square root of x, and we're going to say we're going to take negative f of x, and we're going to say we're going to have 1 over 2, oops, 1 over 2 times x. We're going to open another bracket. We're going to put in here, we're going to say minus 1. We're going to close the set of brackets, and we're going to say minus 3. And then we're going to look at that. So that's what we end up with there. Now, to check to see if it makes sense, we're going to define g of x as this, and then we're going to graph it. We're going to graph them both. So we're going to make a new graph. We're going to say f of x looks like that, and we're going to say that g of x, I'm expecting that it's been reflected in the x-axis, so I'm expecting it to go downwards. I'm expecting it to be dilated, so a little bit squashed. I'm expecting for it to be translated 1, so across to the right, and up 3. So let's have a look. It's kind of what's, down 3. So that's what's happened with that one there. So basically, this will be my function. This is what I'll be writing down. I'll be writing down that this is what's happened. So take you through that again. Reading through, it's 1 over 2 because it's 1 over n. So a f 1 over n x minus h. So we end up with this type of thing here because that's what we substituted in.